Hello everyone. Today I'm going to explain you how I created this simple linear regression model. So before that, let's understand what is the problem statement. We are just uh, predicting the salary based on the years of experience of the employees. Let's start. So here I have imported the libraries. I have imported linear regression from SQL scikit-learn, and then I have imported matplotlib for visualization, pandas for data manipulation and data frames, and NumPy for mathematical computation. And then I have loaded this data set from Kaggle. I have extracted and I have given the path to the data set, and then I have stored in the CSV file. And then I have uploaded in the data frame. After that, I have used this head function to check, to check with the data, how the data looks like. So here, after the data exploration, I have defined the target features, and the target variable. Our feature is nothing but the years of experience, and our target variable is nothing but your salary, which we are going to predict based on the experience. I have plotted the scatter plot to check that whether there is a linearity in the, there is a linear relationship in the data or not. So here we can see the data is pretty linear. So before that, I want to explain the equation behind this linear regression model. So basically, we are using this y is equals to mx plus b. Y is nothing but the target variable. M is the slope. X is the years of experience. The input column plus the b, which is the intercept. As we have checked out the data is linear, we are then differentiating the input and output, which is quite important to check to do before training the model. After that, we are using this from scikit-learn, we are using this train test split to split the data into training and testing. So I have used this. I have used 20%. I have kept 20% of data for the testing and 80% for the training. Here, I'm just checking that whether it has, whether it performed correctly or not. And then we are moving ahead to train the model. I'm using this LR function to train, and then this LR fit, and then using X train, Y train to train the model. The model will fit and train into this. And then after that, I'm just basically checking after the model is trained, I'm just checking the scores. So this is by default, when we use this LR.score, it uses the default function, default evaluation metrics, which is R2 square. So the value for R2 for X train and Y train is 96. And for X test and Y test is 90. Use this Y predict function to predict on X test. And I have from X test, I have taken some a year, 9.7 year of experience, and I have checked what is salary, what the model is predicting, and it shows that it's 115. But here we can see that the model, the results were 1112. So it basically shows that the data has some noise. And after that, I'm using the scatter plot to show the how the linear regression has formed. So this line is also known as the best fit line. Evaluation metrics from scikit-learn, I have imported this R2 square, mean square error, and mean absolute error. And then using this Y predict, I have predicted this from X test, and then I have for each matrix I have then thrown this Y test and Y predict to evaluate how accurate the model performed. Sorry. Here we can see that the R2 square is 0.9, and RMSE square is 7059, and mean absolute square error is 6286. So mean absolute error is nothing but it measures the average difference between the predicted and actual value. And mean squared error is nothing but it measures the average squared difference between the predicted and the actual values. And root mean square error is nothing but it measures the square root of the average square difference between the predicted and the actual value. So let's just break it down. What this value says. So R2 square is 0.9, which is nothing but 90%. So the model explains the 90% of variance. And then the RMSE is a 7059. I'm sorry. So it says that the predictions are off by around this value. And mean absolute error is nothing but how much mistakes the model is making for the prediction. And here we can see that the root mean square error is greater than mean absolute error. So, it is larger than this value, mean absolute error value. So, which shows that there are few big errors and maybe outliers in the data set, which we'll do later. Then we are going evaluating the relative root mean square error. So it shows that it is 0.4%, which is 0.04, which is basically 4% of the actual value. So this means that the model is doing well. I'm sorry. And then we are checking these coefficients and intercept, which are pretty critical for the linear regression model. Sorry. And then I have just plotted this coefficient and intercept, which we did. And here I have already explained the formula we use for linear regression. So let's summarize this. So it says that the model actually predicted 90% of variance, and the error is our only, the error is just 4% of the actual values, so which is kind of reliable for decision making. Also about the linear regression just finds the straight line between the input and output. It just helps us to make a prediction and understands the relationship between input and output variable. And metrics like the root mean square errors, R2 square helps us check whether how our model performed.